Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shahzan Azrai bin Manapis from Group A. Today we will present about the air pollution index. Before that, I want to introduce our team members, which is myself, Ahmad Shahzan, Muhammad Hamizan bin Zabidi, Muhammad Nur Azmizi bin Razak, and Muhammad Zuhimi bin Muhammad Nazmi.
Hello, hi, Assalamualaikum. My name is Muhammad Zulmi bin Muhammad Azli, and I'm going to present about introduction. So, in our introduction is simple linear regression is used to estimate the relationship between two quantitative variables. So, you can use simple linear regression when you want to know how strong relationship is between two variables. For example, the relationship between rainfall and soil erosion. Next is the value of the dependent variable at a certain value of the independent variable. For example, the amount of soil erosion at a certain level of rainfall.
Okay, for our group study case, is air pollution is becoming a major environmental issue in Malaysia. So this study is focused on the identification of potential sources of variations in air quality around the study area based on the data obtained from the Malaysian Department of Statistics. Air quality parameters from 35 monitoring stations in 2000, year 2000 were gathered. So air quality parameters are consisting of air pollution index maximum and air pollution index minimum. Hence, this data indicated that for the future and effective management of the Malaysian air quality, an effort should be placed as a priority in controlling point non-point solid pollution sources.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Mizi bin Razak. My ID metric number is DN 2091. So I will present about graphical methods. So for the graphical method, the title of the graph is dataset of air pollution index maximum and minimum from 2000 until 2004. So the solution is, first at all, we draw and label the x and the y axis, which is the x axis is air pollution index maximum and the y axis is air pollution index minimum. And then we plot each points on the graph. So the method that I use is using Microsoft Word to make the graph. So that's for me. Thank you.
So now I am going to present about simple linear regression model. So simple linear regression method. So the method that we're using are least square method. So from the table, we know that the frequency, which is n, 35. So from the table, we have to find the sum of x, sum of y, sum of x squared, sum of y squared, and sum of xy. So next, from there, we use the formula which we have to find the SXX, which are sum of the square difference of x. The formula is sum of x squared minus bracket sum of x close bracket square over n, and the final answer we get is 387756.29. So after that we have to find the SXY, which is the product of difference x and y. So the formula is sum of xy minus sum of x times sum of y over n. So the answer you get is 322.71. So after we get the value of sum of xy and sum of xx, we'll use it to find the beta 1. So the formula for beta 1 is sum of xy over sum of xx, and we get 8.32 times 10 power of negative 4. After we find the beta 1, we have to find the beta 0. So beta 0, the formula is y bar minus beta 1 times x bar. So the formula for y bar and x bar is sum of y over n, and for x bar sum of x over n, and we get 6.3522. So by using the formula y equal to beta 0 plus beta 1x, we replace the value of beta 0 and beta 1 to get the simple linear regression model. So the final answer is y equal to 6.3522 plus 8.22 times 10 power of negative 4x.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamizan bin Zabidi, and I will continue this presentation for the coefficient of determination. Okay, and then after we obtain the value for the SXY and SXX, we will substitute these two values into the formula of B1, which is we will get B1 is 0.0801. So after that, before we will substitute this B1 value into the formula as SSE, we must first find the SYY value. So SYY value we will obtain, which is 1306.6x57. So after that, we will substitute this SYY value and B1 value into the SSE formula. So we will get SSE, which is 1162.746, and then we will get to find R squared, which is coefficient of determination, which is the formula is 1 minus SSE over SYY. So we will obtain R squared, which is 0.1102. Okay, firstly, to find the coefficient of determination, which is R squared, we must obtain for the summation of x, y, x squared, y squared, and xy from the calculator. So by obtain all this value, we can substitute all this value into the formula for the xxy and xxx. So we will get sxy with 1797. Meanwhile, for the sxx, we get 22,442. Okay, so after we obtain the value for the R squared, the conclusion for the coefficient of determination is 11% of the total variation is explained by the regression line using the independent variable.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shahzad Azrai bin Mat Nafis. So without wasting any time, let's go to the correlation coefficient. Alright, for this part, the first step that we need to do is find the interpret of the Pearson, which is R. So R equal to SSY over square root SSS divided by SYY. Okay, for the SSS, the first one we need to take the value of EX, the power of 2, 438,277 minus 1 over 35, the number, and then EX 3815, the power of 2, and the answer is 22442. Next, we need to find SSY, which is for the SY 26431 minus 1 over 35, the end. Next, 3x15 for EX for exponent, for sum x, and multiply the sum of y 226 equal to 34.1429, and the last part, which is SYY. So just take the y square, which is 2766, minus 1 over 35 the n, and sum of y, the power of 2, which is 226. And the answer is for SYY is 1306.6857. Okay, next we just go back to the our formula for R for interpret the Pearson, which is we just substitute the value that we get before this, which is for SSY 3734.1429 over the power of square root SSX, which is 22442 multiplied by 1306.1429 for SYY, and the value for R that we get is 0.6897, which is this value is between from 0.5 to 1.0. Okay, lastly, conclusion for correlation coefficient is a Pearson correlation coefficient of 0.6897 indicates a positively strong linear relationship between the variable. Thank you. Alright, for the conclusion, we have included and applied all the topics that contained in chapter 6, which is consists of graphical method, simple linear regression model, coefficient of determination, and correlation coefficient. In graphical method, all of the data has been recorded to form a graph relationship of air pollution index, maximum and over air pollution index, which is minimum, and it has shown that the graph is inversely proportional. So the calculation for regression equation, where the result is y equal to 6.3522 plus 8.32, you multiply by 10 to the power of negative 4x. The result obtained for the R square value is 11.02%. And the last application that apply in this group project is correlation coefficient, which is the R value by using the formula R equal SSY square root SSX multiplied by SYY. So after the correlation has been done, the R value that we have get from the formula is 0.6897. That's all from me. Thank you. So that's all for our team members. Thank you. Bye-bye.